Hello YouTubers. This is a new video to talk about a proposal project to allow API developers in the .NET ecosystem to communicate with their APIs using link expressions. So the idea here is to be able to write down a link expression, send it out to your API, and your API will be able to execute it while you are still you don't see any difference between communicating with a local storage using link expressions versus using link expressions to communicate with an API. It should be exactly the same thing. This approach is something I've been thinking about for a while. There's a lot of technologies out there that allows you to query your data. Needless to say, there's OData, there's GraphQL, there's so many different approaches to allow the navigation and being able to pull the data and shape the data the way you want. And in this video, I'm going to show you my own approach, something I've been thinking about, for a while here. And I want to be able to push code, link expressions code to my API and actually get data that matches exactly the functionality that the API can support. So how do we go about doing something like that? It's really simple. I went ahead and built a little library. I called it RESTful Link. RESTful Link. So here's RESTful Link. It's a very simple library. The library will enable you to RESTful Link. It's available as of today on NuGet. So if you go to NuGet.org, I just published it, so it probably didn't get indexed yet. But if you type in RESTful Link, you'll find this library right here. And what this library is basically doing, it's really important for you to understand. This is a beta version. It's just a very new project. Just an idea that I've been playing with in the last few days. And what this library is going to be doing for you is that from your client side, even from your API, from your consumer side, your API consumer, you'll be pushing link expressions, and the API will be able to execute those link expressions on the existing data storage, which eventually will execute in the database or in memory if your database is in memory, and then be able to return back the results no matter what these results are, so they don't have to adhere to a particular type. So how does that really work? Let's go ahead, let me show you what this really looks like. So as of today, I have this simple, really simple API that goes and pulls a bunch of cities from a database, right? So you have a city, the city has an ID and a name and a state, longitude, latitude, just very basic things. It goes and calls a city service, and the city service calls a storage broker, and the storage broker is using the entity framework to literally just return the data, the DB set. So there's no magic there. I'm just hitting the database, getting an iQueryable out of the database, and I'm just rendering it once it is time to resolve that information from the database. Just as simple as that. Let's run this API first without adding anything to it, and let's see how this API is going to behave. It has a nice Swagger general with if you're starting ASP.NET Core APIs with .NET 5, you're gonna get that nice Swagger generation out of the box. You don't have to set it up or anything. It's almost a standard now, so may as well everyone to go ahead and use it. So see, I hit the API and it gave me back two records, one in Redmond and one in Des Moines, Iowa, one in Redmond, Washington, one in Des Moines, Iowa, and just a couple of IDs. So I have a couple of records in my database, and these records basically they come in from the database directly. So it's coming from the database, rendering on the API. There's no magic there. Now, what happens if I want to say, give me only the cities that are named Redmond across the entire state, entire nation? Give me only the cities that are called Des Moines. Give me only the cities that have longitude of certain value. I don't have this query option right now. Right now, it just spits out everything it has in the system. So it has like some 60, 70,000 cities. It'll spit all 60, 70,000 cities at the same time. Let's go ahead and add RESTful link to my controller. So I can go here and say, let me show you how simple this is. You can go and say manage my NuGet packages and just type in there RESTful link. And then you can add the library into your ASP.NET API just like this. So I added ASP.NET. And then what I'm going to do here is that I'm going to go and reference RESTful link in my API controller. So RESTful link like this. And then all I really have to do, there are two things that you have to do here. You need to build a globals contract that basically contains all your data sources. So I'm going to go ahead in here and define a little class. I'm going to call it globals that takes a generic type and implements iGlobals. iGlobals is coming from this RESTful link library. So if you say iGlobals T, generic type, iGlobals will force you to specify the data source that you're passing in that has to match a particular terminology. And I'm going to tell you why later it has to add a particular terminology in here. It comes in with no particular implementations. So let's go ahead and just do a setter and a getter in here. So here's a setter and a getter. So this is the first step. You create a little class. You may as well put this in your models section or your models folder in your controller. And you're calling it data source. That's the number one step. The number two step, what you're going to do, I'm going to go ahead in here and say var results. I'm going to go and say await RESTful link service dot run query. Run query async. And this run query async is going to take a couple of things as parameters. Now, bear with me. There is a new input parameter that you need to add called lin query. You know, I merged link and query together. I know the Q in there is for query, so link query. So I'm going to pass this link query there. So that's what's coming from your consumers. That's the raw string presentation of your link expression. And then under that, I'm going to define a new instance of globals with the type that I care about, which is city in this instance. That takes in a data source, which is whatever is coming from my database, which is all cities in here. All right. Now, because this is an awaitable kind of expression, we may as well just go in here and say value task, because it's awaitable, value task, and let's make this async. All right. We need some references, control period. You get your value task done. So what did I do here? I created this little bag, globals, variables, that takes in a data source. And I have a link query in here. I added a link query as an input parameter. It's an optional input parameter. It doesn't have to be there. It can be null. And I'm basically calling this method in here, link RESTful link service run query async. It takes in your data source and your query and returns a bunch of results. I'm going to put my results in here. Right? So 1, 2, 3, 4, 5, 6, 7 lines of code. 7 lines of code. You modified your entire API to take in a new input parameter that is not mandatory. And you're calling in a method that's called run query async. And it takes in that query and then it runs it against your existing source. Now, what kind of power did I just add to my existing API controller? Let's go ahead in here and see what I did. If you go here, you'll notice a couple of things. Your link query is in here. If you go and execute without adding any value inside that link query, your API is still going to work like a charm. It's still returning the two cities without any problems. But then here comes the magic. Let me zoom in a little bit so you can see what's happening. If I go ahead in here and say where city.name equal Redmond, see, I'm writing basically C# code as an input parameter. If I go and do this and click execute, see what happens? It filtered the information for me. Now we know that this actually executed on the server itself because I don't have a client yet. We know that this query ran and executed directly on the database. Not even the API in memory, it actually executed on the database itself. Let's get a little crazy. I could go and say, I can chain this and I can go and say select city, new, I'm creating an entirely new object on the fly. And I'm going to go ahead and say city name equals, right, city dot name, like this. See what I did there? I basically said, find me the cities that are called Redmond, and change the entire model that's coming back from the system and make that model return something absolutely different from what I have already today. So if I run this, look, I have a completely new model in here, and this new model has the data that's in there. You can literally do in this box everything you can possibly imagine from a link query standpoint, and it'll still execute on the server and still run like a charm. You can think of all the kind of crazy things that you can do. You can do count. I just want to do count like this. How many do I have on the server here? The result is 2, right? I can do order by, like the existing order basically says, you know, show me Redmond and then Des Moines. But Des Moines, the D letter comes before R. So I can go here and say order by city.name, like this. And I can run my query and it's still going to give me the order Des Moines first and then Redmond. I can say I don't care about all the stuff that you have. I just want city.name like this. Execute. And here it just gives you a list of just the names of the cities. So all the kind of capabilities that you want to have in a query language when you're kicking off. You can even, if your API is supporting more link, which is another library that actually adds even more functionality, you can pass this through and your API is still going to run it flawlessly without any problems. This is all good and dandy until you start actually writing production code, something that you really care about, that you want to run in production. What does the client side of this look like? We made the API accept link queries and run them like this, like a charm, you know, hit the server, you know, do all kinds of operations without any problem. But how do I wanted to provide you with a nice client. See, your experience as an engineer is actually what I care about here. So I wanted to give you a client that you can use that doesn't make you feel the difference whether you're talking to an API or you're talking to a local storage or just running against a list in memory. It shouldn't change anything at all. So how do you go about building a client that does these capabilities? Here's the beta client that I have for you. I'm going to go ahead in here and create a completely new console app in here. And this console app, I'm going to call it is a console app. I'm going to call it City API Consumer. Just a random name, just any name I could come up with. So here's my City API Consumer. And what the City API Consumer is going to actually run the query in the client side without you actually feeling that you're running against the server. How does that work? I'm going to go ahead in here and I'm going to pull in the RESTful link, the same library. You know, I didn't break it into client, server, any of that because the code base is very small. I'm going to walk you through the code base and how this works in a little bit. So I'm going to go ahead in here and just type RESTful link. Here it is. So here's the library. So I'm installing RESTful link. RESTful link is also kind of, at least the client side, is dependent on another library that I created a while back, which seemed to be, you know, have had a bit of success with the community, which is called RESTful Sense. It basically handles all the exceptions that happen from the API and turn it into something more verbose and more easy to communicate with and deal with. So okay, so this is I added in the RESTful link library. Now let me copy my city model in here from my API. So I need my city model. So I'm going to go into the API here and go into the API model. And I just need this API city model right here. So here's my model. I'm going to put them all in one file, even though I don't necessarily do that in production code because it's just gross. So okay, so here's my city model. So what I want to do, I want to build a little function in here. Here's static. I want a function that returns a list of cities. a list of cities. So there's this new model that I introduced here called link queryable. Link queryable is basically where all the magic happens. This link queryable will take in your model, city model, and you can call the function getCities. Just something as simple as that. It's not asynchronous because it doesn't really execute until you tell it to execute. So it's operating just like an iQueryable function, but it hits the API instead of running in memory. So you don't have to pull everything from your API and then you filter it. You can hit the API and let the filtering happen on the server first, the more powerful, more distributed server, and then just let your thin client just handle the result back. What does this getCities look like? I'm going to go ahead in here and just say new link queryable model with a city. And this link queryable model has a couple of properties that we need to have. All right, what are these properties? First of all, I want my HTTP client. If you're building this for production, your HTTP client should be already ready from a dependency injection. So you're just adding it into the system. You're just attaching it into you. But in here, because this is just an example, I'm just going to build it on the fly. It's using the RESTful Sense client. So I'm just going to go ahead in here and say RESTful API client. Here's my RESTful API client, and inside that I just want to add in the base address, which is a new URI. The base address is basically your API endpoint, your API URL. So which is, it's this guy, not the endpoint, just the base URL. So I'm going to copy it in here and just put it right here. And in addition to that, it wants a relative URL. That's the other thing that it wants. Other than that, it doesn't need anything else. It knows what to do. And the relative URL is basically the rest of that URL that you have in here, which is API/home, like this. API/home, you set up your client, you're done here. So you're returning a link queryable of a city. Someone might say, I don't understand this model, so what does it do exactly? I'm going to show you in a second what's it do. This is all you had to do. You just pulled in the model from the API, and then you set up your link queryable function that says getCities. That's all that you did, right? In the real world, this would be something like cities, like this, right? But I'm setting it on the most basic API that you can think of. Now, let's change this guy into a sync task, our main method. Let's change it into a sync task so we can execute asynchronous operations. And let's go ahead in here and do a list of cities, which is what I'm going to get back from the API. Cities. And I'm going to start doing this. You can go ahead in here and say await getCities. This guy doesn't require await in and of itself because it's not an awaitable. It doesn't actually return a function. But what you can do is that you can go underneath that and start chaining link statements. I can go ahead in here and say city.name equal Redmond, and I can chain another one underneath that, which is where city.state equal Washington. And when I'm ready to execute, I can go ahead in here and say toList async. toList async basically is me saying go ahead and now execute on the API. So let me pull in the reference in here for the list. So I went ahead and I said, give me Redmond, give me Washington, which is basically the same city, and a city in the same state, and then you basically are executing to toList async. All I gotta do now is go ahead and just print this result. I can go ahead and do console write line cities, and if I put a breakpoint in here and actually run my consumer against the API, this statement, these little link statements that I have in here are actually going to execute against my API. So see, I got the statement in here. I should have only one city. And if I expand this a little bit, here's my city right here. See this magic? So you're basically writing a query on your consumer side, something completely detached from your API. And you're basically running a query, and it's coming back and it's querying that data for you in a fluent manner. right? You can execute a lot of other operations. One of my favorite is that I can go ahead and hit in here and say string, and I can go and take all of this, and I say just give me the names of the cities that are in my API. I don't need anything else. So select city name and turn that into a string value like this, and give me just the city names. I don't need the longitude, I don't need the latitude, I don't need any of that stuff. If I run again my API, my consumer, if I look into the cities here, here you go. Here's all the city names that you have, just like that, right? You can even do a lot of crazier things, right? Like you can do order by, you can do, I don't know if I included order by in the API, I'm gonna have to support that, but you can do first or default, you can do count, you should be able to do skip, and you should be able to do take, right? So if I go ahead in here and say take just one result out of all the cities, I don't want the rest of them, it'll literally go and pick up one exact city from there. So if I run like this, oh, I need to change the types back to cities. So let me change this to city, because it's going to give me actually one city in here. So here's a city, and if I go and run this, there you go. It should give me just one city from the top, which is Redmond in this case. So you see the difference here is that you don't have to learn a new query language. You don't have to worry too much about too much configurations. You're just adding this one method that basically glues, it's basically a bridge between an existing very strong functionality that you already have in C# and .NET and the Entity Framework and the .NET ecosystem in general. You can have the link expressions, pass in predicates back and forth. All we had to do is just, all I had to put in this is just to pass that predicate over the wire, you know, and let your API handle it and just give you back some details. That's all that it is. There's no magic there. It's just as simple as that. Now, let's see so what do you get out of this? Let me show you the source code. Let me show you how this thing works actually in the real world. If you go to GitHub in here, you will see my most recent library published repository. This is open source. Feel free to go in and modify the code and do whatever you want with it. You know, it's under MIT license, so you are more than free to learn from it. Let's look at the service first. So what does this service really do? You'd be surprised. This is all that the service is doing. What it's really doing is that it's running a C# script in a little, this is the Roslyn approach where you're actually taking advantage of being able to run C# script as a string. So we stringified the link query in here, and I'm passing this link query down to a data source that's coming from my globals, variable, the input parameter that you're passing in. So all that you're really doing is that you're giving me your data source in here, and I'm already receiving the link query from the API endpoint, and I'm running a little script in here. I'm just appending your link query to your data source. As soon as I did that, boom, you got the functionality. Simple, precise, easy code to understand and to use. There's no magic there. So this is the API side. This is how the API works. It's about 20 lines of code, you know, from 16 to 30, about 15, 14 lines of code. That's it. Okay, so that's this part. It uses some sort of reflection to add in a bunch of references, and then it's just running it as a script. Thanks to the Roslyn platform and the folks that actually built this, now this is possible. You can actually do this. And what it does is that it's running asynchronously because you're executing this asynchronously, and then it's returning an object. Let that object be whatever you want. Count, you know, an entirely new object like I showed you in here. It can be like in here we basically return strings, so it's not really tied to any particular type. It does take a generic type so it knows what to do with it, but that's all that it does. You know, it just takes this generic type so it knows the globals, the kind of data that's coming in. This is just an enforcement of generics. You know, it's just an enforcement to know what kind of type of data that you're going to have to work with. But other than that, we're returning an object, whatever you want it to be, let it be. So that's the server side. If you look at the client side, it's a little bit smarter, right? So if I go in the client side, you'll notice a little bit of code. Now, this is not 14 lines of code. It's a little bit larger than that. You know, this is the link queryable object that you have. And this link queryable object takes a client and a relative URL and a query and data. So these are the parameters that it cares about. And every time you say where, it takes that predicate that you pass inside the where, puts it in the data option and stringifies it, and then does a little bit of string manipulation to trim out the additional details that comes out of stringifying an iQueryable. In this case, the iQueryable with the data itself, it basically trims out all the little details that an iQueryable stringified variable statement looks like. So you end up at the very end with something like this. You end up with this query. You basically take the HTTP utility and encode the stuff that's in there because you're using parentheses and ampersands and all that. Also, the predicates themselves, they don't really take the ORing and the ANDing that you do and let it be. It just translates it into AND also or else. And because this is just trying to serve very basic functionality, it has this little clean up query kind of functionality that maps it back to the original statement that you made. Every time you chain an event, it's basically saying select and return the original link queryable, and it updates the query. Every time you chain an event, it takes out a link query and updates the query, and it runs all at runtime. And at the very end, when you say toList async like this, it actually takes the true query and sends it up to the API with a link query parameter. That's why the link query parameter has to be there. You have to pass in a link query parameter. You have to allow your API to actually take a link query parameter. This is all it. The only other thing that is not that I haven't talked about yet, which is basically the model, which is iGlobals, that enforce using a data source as a parameter name, because in this string interpolation magic that we're doing on the server, what we're really doing is that we're taking this data source here, it's hard coded in there. So I have to force you with a contract to use data source as a name for that globals variable that you're passing down to me. Someone might ask, why don't you just pass the data source in here and create your globals in here? I said, I wish. There's some limitations that your globals variable for a C# script kind of functionality to be defined at the top level of the class. If you're using this as a DLL, you're kind of restricted there. You can only do so much there. So that's pretty much it. I hope this is useful to you. I hope that you can see this. I'm going to add some documentation and add all the bells and whistles. You can actually go, like I said, if you go to NuGet.org and look for RESTful link, you're gonna find this library in there. I just released it just a couple of hours ago, and I did a little bit of testing just to make sure that everything is functioning as expected. Here is your API. Run your queries, run your select, do your calculations, for God's sake, for all I care, and it's just gonna work like a charm. You know, you can navigate. If you can do it in C# code in your API, you'll be able to do it in here. The client needs a little bit of work, obviously, because we want to support all these kinds of different functionality. And I'm more than happy. I'm open for suggestions. But other than that, that's pretty much the whole project. Now, someone might ask, you know, so what are the pros and cons? You know, there's already technologies out there that actually allow us to navigate and query and select and, you know, form our data the way we want. So there's a bunch of challenges in here. So first of all, link query cannot run between, it's not technology agnostic. It's very, very, very tied to a particular technology within the .NET ecosystem, right? So it's not a standard like Open Data where you can go and basically, if you have a Java application or C++ or you have Python or Scala or C#, they all can talk to each other because they're all following the same standard, which is the Open Data Protocol, right? They're all following the same thing and they have their own implementation of that, right? It's true, they vary between one technology and the other, you know, and it's much, you know, more scalable than RESTful link, but that's one of the cons that we have. One of the pros is that you don't really have to post a query. You're still doing a get. Unlike GraphQL, Graph makes you post a query so you can get back data, which is kind of weird and odd. You're actually getting data, you're not really posting anything. So it's a little bit of a weird implementation from a RESTful standard standpoint. The other limitations that you have with this is that you are really tied with what's available and what's not on the API level, right? So if your API is not ready to take in link expressions, or it's not ready to take particular predicates, it won't execute it. It'll say, I'm sorry, I don't have this available. One other things, it has a huge security issues, right? Meaning that anybody can literally post an entire blob of a for each that's running forever into that link, and it takes down your server like that. Unless your server is configured to time out after a particular period of time and detect that, there's no security measures yet. It's a very young, small NuGet library that still has a lot of potential. I'm just trying to experiment with what can happen. The pro side is that whether you are querying that data from the Entity Framework directly or whether you're querying it from the API, it's going to look exactly the same. Even the Entity Framework now gives you to-list async as well. So you can't really tell the difference. If you go back into your client and looking into your City API consumer, you can't absolutely tell the difference between whether you are actually navigating on a native model or you're actually building a query to hit a particular to hit a particular endpoint. Absolutely no difference there. You can't tell because your client, if this is hiding behind a broker, as you should, if you're designing your system, if this is abstracted away, then all you really have to change to switch between an API and something else is to change that link queryable type to iQueryable, and you're done. Everything else should work exactly the same. You have your business logic layer is none the wiser whether you are actually hitting an API or you're hitting a storage broker. And this is the kind of abstraction that I am aiming for. The whole reason why I'm putting the time and effort into this implementation here. First of all, you don't want engineers writing queries by hand. That's really bad. You don't want them to do a lot of strings interpolation, a lot of strings work, and you want them to use something that they're familiar with. So this implementation is more about you than the technology itself. I want to make your life easier when you're communicating with an API and trying to get some data. So that's pretty much it. I hope that's useful to you. If you have any questions, comments, concerns, if you have another approach in mind that you think might actually improve the experience for the engineers, please feel free to reach out, drop a comment in the comment section. More than happy to hear your feedback on this, and don't forget to like and subscribe. Thank you so much for watching. See you in another video.